Hello everybody! I want to talk to you today about a really fun topic, which is how eating food can actually cleanse your body. Specifically, I'm talking about fiber and how it can bind to certain contaminants that we're exposed to from the environment so they can be removed. I love this topic because people often think about detoxification in terms of water fasting or doing a juice cleanse, and while the absence of food does have certain benefits, like it induces autophagy, which is a form of cellular cleanup, and lipolysis, which is breaking down fat. Those things are great, but in terms of detoxification, eating food actually does a lot of the heavy lifting when it comes to removing those really recalcitrant, persistent type of contaminants in our bodies. So what are some of the contaminants that high fiber foods can help us to detoxify, and what are some specific sources of fiber that are best for this? I will give you a brief summary of this in this video. So first, for a quick introduction, my name is Kelsey. I'm a PA and I have a master's in crop and soil environmental science, and I just really enjoy digging into academic literature to find simple lifestyle solutions to help live a healthier life. So if that's something you're interested in, then subscribe for future videos. So many compounds that we're exposed to in the environment are lipophilic compounds. And to a certain degree, lipophilic contaminants will be converted into polar metabolites that are water soluble and excreted through the urine. But primarily, lipophilic contaminants and their metabolites are excreted fecally. However, a lot of them don't get excreted, and a significant portion remain in the body, having a hard time making their way out. Enterohepatic circulation is a basic concept that plays a big role here. In this process, lipophilic contaminants, meaning fat-soluble contaminants, are secreted from the liver into the bile, where they travel to the small intestine and then are reabsorbed by intestinal capillaries. From there, they travel via a vein called the hepatic portal vein to the liver. This vein carries nutrient-rich blood to the liver, so the contaminants ride this vein right back to the liver instead of being excreted. And this repeated cycle of reabsorption significantly increases the overall contaminants exposure and potential toxicity within the body. As a side note, this is the same physiologic process that also recycles bile salts, drugs, and other substances as well. So in terms of lipophilic toxins, what are some of these compounds specifically? Most persistent pollutants are chlorinated compounds. They have multiple chlorine-carbon bonds, which make them quite stable. That stability is a quality that often confers utility for industrial purposes, but it also causes them to be persistent in the environment. Their stability is also reflected in their resistance to chemical alteration by reactions, including those that are enzymatically catalyzed in the body. Some of the lipophilic compounds of interest are PCBs, PBBs, PAHs, dioxins, hexa and pentachlorobenzene, and others. Many of the very terrible lipophilic persistent pollutants have been banned, thank God, but they are still circulating in the environment through various cycles in wildlife, soil, and waterways. I think people would be amazed to realize how long certain chemicals can stay in the environment. I remember when I was working in environmental consulting years ago, we were taking samples of groundwater at a Superfund site that was a former dye factory that had closed in the 1980s. We were just maybe about 30 yards from the shore of the Hudson River in upstate New York, and the groundwater was bright neon yellow from hexavalent chromium that had just been hanging out there since the 80s. So a lot of these chemicals can be really persistent. It's really actually just mayhem, and this is certainly the case with these chlorinated compounds as well. For example, PCBs were banned in 1979, but prior to that, they were used extensively as coolants and lubricants in electric transformers. And today, they continue to be found in fish, river sediment, construction site soils, stormwater, and a lot of other places where they shouldn't be. So what are some of the effects? A wide array of research has demonstrated toxicity, carcinogenicity, reproductive and developmental problems, immune system damage, endocrine effects, and other metabolic alterations caused by these chlorinated lipophilic compounds. In fact, for most of these compounds, a no effect level has not been established, meaning any amount is thought to be detrimental. These substances have frequently been found in breast milk and in human tissues. So that is all kind of a bummer, but we do have some ways to help ourselves out. Indigestible polysaccharides in particular have been shown, in rats at least, to enhance the excretion of a compound pentachlorobenzene. Inulin, for example, is an indigestible polysaccharide that you can supplement with or add to beverages. In a study which I will cite in the description, rats were given experimental diets, each with a different kind of fiber. They were dosed with pentachlorobenzene and then kept on the high fiber diets for 7 days. At the end of the study, the level of pentachlorobenzene was lower in the liver, kidneys, and adipose tissue of the animals that ate the indigestible polysaccharides relative to the control group. The body weight and adipose tissue mass were also significantly lower in each of the polysaccharide groups relative to the control. The authors thought that the lower adipose tissue mass may have actually played some role in the fact that less of the pentachlorobenzene was retained. I was really excited to see that indigestible polysaccharides had this effect because I actually really enjoy inulin. I think it makes a nice sweetener, just something that you can add to coffee to easily add some fiber to your day first thing in the morning. Another study looked at the effect of 10% fiber by weight in the diet on the excretion of various compounds. They compared rice bran, burdock, corn, and soybean fibers. All of the fibers significantly increased the excretion of dibenzofuran and dioxin congeners relative to the control group. Another mouse study demonstrated enhancement in fecal excretion of dioxin isomer in mice by several dietary fibers. In this study, the fecal excretion of dioxin in the group fed a non-fiber diet was 21% of the dose, while the fecal excretion in the group that was fed a 10% rice bran fiber diet and 10% spinach fiber diet were 44 and 45% respectively. So more than double the excretion of the dioxin just by adding fiber to the diet. So I know most people probably don't have the appetite to hear me continually list rodent studies, but there are more of them, so I will post some citations in the description. Microplastics have also been shown to be reabsorbed in the intestine and recirculated through the enterohepatic system. Fiber may help to detoxify these microplastics while they're in the gastrointestinal tract. There is less research investigating this for now, but hopefully more to come in the future. But based on the physicochemical properties of dietary fibers, they may bind to microplastics and promote excretion. It is thought that insoluble fiber is likely optimal for binding microplastics. Studies have shown that after insoluble dietary fiber interacts with hydrochloric acid, as it does in the stomach, honeycomb-like hole structures are formed, and the specific surface area and total pore volume of the particles increase, increasing adsorption sites. An experimental study conducted by Yen et al. Explored the efficiency of removing polystyrene microbeads from an aqueous solution using untreated coffee grounds. The results show that microplastics can be effectively adsorbed on coffee grounds in a wide pH range, meaning this effect would likely be maintained in the environment of the GI tract. Presumably, this effect would occur for other types of insoluble fiber as well. The main mechanism of absorption is electrostatic interaction and hydrogen bonding, because the positive surface charges on the microplastics interact with the negative surface charge on the fiber. Pretty cool, right? So the fact that fiber can help to remove these contaminants sort of, for me, calls into the question the benefit of a juice fast. I personally think, why not just include fiber? If you're someone who is motivated to do some type of a dietary cleanse regimen for a few days, as many people do, I think a smoothie cleanse would make far more sense than a juice cleanse. This is because quite likely during a cleanse, you may mobilize some fat stores, which brings those contaminants from adipose tissue into circulation. So why forsake the opportunity to enhance the excretion of those contaminants with fiber? But the take-home message overall is to include fiber in your meals often throughout the day to have a 21st century adapted diet and do the best we can with all these contaminants we have around. So that's all for now. If this type of content is of interest to you, then I encourage you to subscribe.